we'll be talking a little bit about how we utilize the warn and forecast system this past spring. So first off, just want to talk about why was the Twin Cities office a good example to look at for looking at WoFS this past year? Well, this past year, we had our second most severe thunderstorm warnings in a month. You can see the 159 there for May, which is right up there with the top compared to some of those years that we had with typically a little bit later in the season, more like June for a lot of our busier months oftentimes. Same thing got carried over with tornado warnings. It was our second highest as well for tornado warnings issued. So this was a very busy month for us. And since it overlapped with the spring forecast experiment and the running of WoFS, we were able to have multiple opportunities to test out WoFS for a variety of different types of convection to see what happened and how we could utilize it at the weather forecast office level. So just to make sure we're all on the same basis here, just a quick overview of what WoFS is. WoFS is a convective allowing ensemble with rapidly cycled data assimilation. That part is the key part of WoFS. It takes in various satellite and radar data sets, and it's focused primarily on that first 6 hours of lead time. So it's very useful, can simulate all the way down the individual storm level, and it can have a bit of a warm-up period, though. That is one thing that often has been noted with WoFS, and all of the cases today we'll be looking into the different WoFS data. So these are the 9 events here, vary from May 9th, where largely a hail event. May 11th, a little more widespread of all different spear hazards. May 12th, that was the big derecho that happened last year. May 19th, that was had some hail and wind, some significant stuff mixed in there for the wind side. Same thing on May 29th, a little more isolated though on that day. And then May 30th, a little more of a widespread severe weather day. So let's dive in first and look at May 9th. So May 9th here, enhanced risk, which we saw pretty consistently throughout this month here, a 10% tornado, 15% hatched hail, 15% wind outlook. So all hazards in play, but it was definitely highlighting the hail and for significant and tornado with kind of a probability basis. What ended up actually happening, hail with some significant hail, a little bit of wind and some tornadoes mixed in. So let's take a look at what we got from WoFS for this example. So we have 2 different time frames here. On the left side here, we have a WoFS run that was initiated at 17Z, valid for 23Z. And on the right side, we have one that was initiated at 20Z, valid for 2Z. So we're looking at different things here. On the one on the left, the benefit we got with this is this was in advance of a lot of the convective initiation really happening. So we're able to get an idea that the Twin Cities Metro is at risk, which is that area. Those green dots there are hail reports, and those hail reports kind of run along the south and east sides of the metro area. So allowed us to be able to make sure we prepared ahead of time. Although as we got later on the event, this is one where the WoFS kind of kept the hail going on for longer. We can see all that red extend deeper into Wisconsin and kind of made us think it was going to be more significant than it ended up maintaining itself as into Wisconsin. Then on this one, we're looking at the wind chances. So the wind chances are all very low on this. Let us know we were looking at primarily a hail threat day. And despite getting a couple isolated wind reports, it definitely was, you remember from that SBC LSR plot at the start, it was much more of a hail day. So kind of summing things up, so prior to the storm initiation, the WoFS did very well and let us know that it was going to be a hail threat that day. And that really helped us assess where the warnings might be needed in the future to help us in planning our staffing and operations levels. Moving on to May 11th, on this day, yet another enhanced risk, another 10% TOR. This time, though, we have a 30% hatched area for both wind and hail. What ended up happening that day, here you can see a little more, as we said earlier, a little more balanced out, wind and hail reports scattered in. Both had some significant and a couple isolated tornado reports. So let's see what the WoFS provided us for this case. Looking at here, this is a hail cast for diameter, basically severe hail expectations. Similar last time, these are 2 different time periods. On the left, we have a initialized at 17Z, valid for 23Z, and on the right, we have an initialized at 21, valid for 3Z. So you can kind of see the 2 different phases of the event and where the WoFS was expecting things to happen. So you can see it did pick up on the hail threat, although it did seem to have a bit of a southerly bias with this, and didn't really pick up some of the storms that are more there in central Minnesota. Later on the day, after it had a bit more of its warm-up period, it was starting to assimilate things a little bit better, giving us a better idea of the locations, although it still seemed to be a little more biased to the south versus where we're actually seeing the storms come in with those green LSRs coming in right there. So prior to storm initiation, WoFS didn't really provide much with the locations, but did at least tell us what the hazards were, as we saw there. And it did pretty well on evolving and assimilating the storms and making a pretty good improvement between that first and that later one. One thing specifically that we were able to do, though, is with the Warren forecast system, they're showing that significant hail and wind signature possible going towards the Twin Cities area. We're able to use some DSS and also help with the public with the social media post with this particular one here. So we can see with the radar, we had reports coming in for severe, but being able to lean on WASP, know that it was going to maintain its strength as it made its way further east. We were able to put those arrival times in there because we had confidence it actually was going to impact the Twin Cities metro to make people be able to get themselves prepared and ready for those storms before they arrived. Moving on to May 12th, this is a day many of you are probably quite familiar with since it was a pretty big event for the central region. Moderate risk on this one. That's largely driven by that wind risk with that large significant area, very high in percentiles with that derecho threat. A little bit of tornado possible too, and the hail was not really the main threat within the area that we have in Minnesota and far western Wisconsin. So looking at the SBC storm reports, just an absolute indecipherable amount of LSRs coming in on this one. I don't know if it's been knocked out yet, but I think this was definitely one of the highest wind report days the Storm Prediction Center had for their LSR maps. And you can just see very much, very high end day here. So what exactly precipitated with this day? Well, we had a very hot air mass moving up, relatively moist as well coming in. And you can see with this 145 image we have on the left here that we put out on Twitter, the Twin Cities area was still stuck in the 60s and 70s. But then just not too much later, 5 o'clock, broke 90 degrees. So pretty rapid warm up over a couple hours with some pretty impressive heating that day. Allowed for a lot of instability to develop. So just putting this map in here, diving a little bit deeper into this one because it's a pretty big case. You can just see here we have showing this to show the surface-based cape, just how much we had built up in southwest Minnesota. Really diving in with that there, 6,000 joules showing up on this surface analysis. Plenty of shear present as well, 50 plus knots in that area that ended up having the worst of the storms hit. And just kind of a, let's wait for this to reset. So just seeing the whole event go forward with what the watches and the warnings continuing on through there. Storm just trucked us all the way through. Pretty high-end event with this ongoing setup. Much more of a wind threat that evolved into more of a QLCS with some tornado threats as it got a little bit a little later in the event, and especially along that northern side as it tracked through. So what did WASP provide for us? Well, on this one here, we got a lot going on with this map. The black areas are the MRMS reflectivity areas to let us know with where the storm actually was. And then the shaded is for the ensemble probability of getting, gusts over 50 knots. So more or less kind of a severe wind parallel. And then the blue dots are the LSRs that came in. So you can see the LSRs lined up pretty well with that MRMS analyzed reflectivity area. And just seeing that high confidence of pretty much maxed out values really could let you see that the WASP was incredibly confident that this was going to follow through and be a pretty high-end wind event. And the probabilities pretty much only went down with distance due to the inherent uncertainty with time that the storm would maintain itself. So definitely gives you a good idea that this storm is significant, it's going to hold itself together, and to be ready for something big. And a little bit later on with the run here, we were able to really get an idea to see how this lined up with the areas the highest winds. Our highest was a 94-mile-per-hour gust that happened at Madison, Minnesota, which is that black circle there. And you can see the ensemble probabilities there are very high, 90, 85, 90% in that area with where that highest wind gust happened. So this was definitely an event that kind of proved WASP to call people to just see, it's not just to pick out some of the lower end stuff. It can really help you figure out if a high-end event is likely to occur. So just to kind of see what it was like to live in this, there was a wall of dust that came through with this. The outflow with this storm just kicked a bunch of dust up. And the time of year it's going through, we're not necessarily, you know, we got a decent amount of green up by this point, but the farmers were only just starting to get out in their fields and get crops out there. So a lot of dust available get kicked up, and just we're able to come with the winds with the storm and create a pretty impressive sight. And just kind of see it from another location as this storm was going on through. So moving on, I got a couple different events to carry through here. So the enhanced risk train continues, although we had that one moderate, but enhanced or higher continues on. To have a tornado risk a little bit lower here, really have that hatch hail, and also have a 30% wind carrying through on this event. So for storm reports on this case, pretty much carried on with the hail. That was the main threat. So we'll look more only at hail details for what WoFS can provide us. So first on, we're just going to do just a straight 90 percentile of composite reflectivity to try to get us an idea for where things should be kicking off. So you can see here with the WoFS, it has some early day convection near the Iowa border that kicks off, but then there's some later carries on through, and then we get the next round that pops up later in the day. You can see all those reports pop up over the Twin Cities metro and track into Wisconsin. So it gives you a good idea of where things might be happening. Now take a look at a later run in the day here. So you can see WoFS continues to hold a lot of that strength together. So this is kind of similar to that first event we talked about, where WoFS had it pretty good with the first round, but then struggled a little bit with the second round. And then also with that same one, there was a population bias with the hail reports there as it went through the Twin Cities. That wasn't a necessarily higher amount of hail as other locations, just that population there gave us a lot greater density of reports. So looking at something a little bit different here, this is the logistic regression probability of hail. So basically we're talking about the probability of severe hail occurring. So you can see it's really having quite a bit of confidence going more down into WFO La Crosse's area in southeast Minnesota with a lot higher probabilities down there, despite the fact that that's not necessarily where all the hail happened, although they did get some hail in that area. So just throwing something in, a lot of the ways we talked about this stuff was using our internal Google chat room. So this is from our Stu here. He's trying to pick up on some things, and it did seem this day there was some dew point stuff issues going on there that was leading to higher dew points being assimilated into the WoFS, making it more excited in southern Minnesota than it should have been. And that led to some overforecasting of Cape values, which then led to some of those overconfidence values that we saw within WoFS there in the southern parts of Minnesota. So there was a reason for why it happened here with those overdone dew points. Moving on to May 29th here, the enhanced train continues. I got another tornado risk. Once again, it's more on the wind and hail with the high-end risk here, with the wind really standing out on this case. What actually ended up happening? Not as quite as much as you might have thought from the SPC outlook, but we still got a pretty good variety of wind and hail reports, not as much on the tornado side. So this is one day where this shows the benefit of being able to talk with the developers when you're dealing with an experimental product. Locally, we didn't do a lot with WoFS on this case because as WoFS had its initial runs, they were seeing some unusual output from the model. And we're able to use information provided by Patrick Skinner inside of chat to basically not use WoFS in this particular case. So when using experimental data, leverage the developers, they know their product better than anybody else. And that was able to help us not basically over forecast something and give people kind of a false alarm on any kind of severe outlooking we could have done locally with any kind of social media post like we did earlier, where WoFS gave us that confidence to look at the Twin Cities metro despite the storms being in western Minnesota. Now moving on to our last day here, May 30th. This was another one of the really big days that we had. Another moderate risk here, hatched on everything, high percentiles on everything. Just a really big day that happened for us. So, you know, 2 moderates and a bunch of enhanced all in 1 month. You can see how we got all those severe thunderstorm and tornado warnings. So what ended up happening here with the reports, you can see wide swaths of wind and some pretty good tornado activity also happening, especially across western and central parts of Minnesota, and some hail scattered in, but really it was the wind and tornadoes that really were the highlights on this day. So with this day, it was a very rare occasion for us. We actually had a PDS tornado watch that went out, and it did eventually get expanded further east to include the Twin Cities metro, including parts like Minneapolis and everything right over here as well. So here's kind of a look at how things evolve through the day. All right, here's the start. So you can see activity starts up in western Minnesota. You can see lots of warnings carrying on through as it tracks its way east across the state. There's that tornado watch in expansion, and then carries its way all the way on through across the entire state of Minnesota. So pretty big day. Let's see what WoFS did for us. So on this one, we're using something that anyone who's used the HREF or any one of the convective allowing models is pretty familiar with, likely the updraft helicity. So this is once again a 90th percentile, trying to give us an idea of where we should be looking for, kind of more on the high end of things. And we actually in this time have the tornado warnings plotted on here. So you can just try to outline with where the helicity updraft helicity was expected versus where tornado warnings occurred. So you can see there was a bit of a warm-up cycle needed before it was able to start picking up on some higher values. And did have some areas, the highest value didn't really see a whole lot of tornado action, but there was still severe convection ongoing in that area. Looking at the 90th percentile wind gusts, you can see is a pretty widespread signal here. Obviously, the individual convective members of it probably picked different locations, which kind of mellowed out the percentile. So we didn't see like those 90th that we saw with, the derecho day, but still we're seeing greater than 50%. Chance of high wind gusts across a wide part of the area, which lines up very well with what we actually saw reported with those LSRs. And then looking at the regression again, seeing actual 100s popping up, that's kind of an eye-popping thing to see an actual 100 pop up on the probabilities there, to know that the confidence of the severe wind is that high as these storms made their way on through. One thing that was particularly concerning, though, is WoFS member 6 in this example here was taking a large supercell directly through the heart of downtown Minneapolis. So this got us a little bit concerned, because if this actually happens, we want to give people as much lead time as possible. And let's take a little look on the next slide to see how we actually utilized this particular information. So take a look at the radar again to see what happened there. It should be getting the Twin Cities soon here. And right now as the storm's hitting the Twin Cities, so you can see storms happen, but it wasn't quite the isolated supercell that particular WoFS member showed. So what exactly happened here? That one WoFS member was not the only one that did it. It's just a good example where we're seeing from a couple of the WoFS members. So we had a lot of discussions in our operations on how we should handle this and if we should message the chance for the metro area, although we decided against it, and just try to focus on some broader details. And that was largely based upon the various different chat rooms we talked about, talking with the WoFS developers in their chat rooms, our own local chat rooms, and using things like the Sierra Meso chat room to leverage the expertise we have across Central Region to try to help us all together make the best decisions. One particular reason we were particularly focused on this event is our MIC here previously worked at Nashville, and they had a intense supercell that happened in Nashville when he was there, and he wanted to make sure something like that didn't happen again. But we still knew it was a high-end event. We had this quote that comes here from one of the developers, if a discrete storm can get going. He saw really high SDP and UH values to suggest it's one of the highest end events he had seen within WoFS over the past 3 years. So we were on alert, but we didn't want to give too much of a false alarm chance. So we held back and it ended up being on the right side. But we were ready, and we did it more on a staffing level to make sure we were properly staffed in case it could happen. So just seeing some of the pitches that happened this day, you can see there were multiple tornadoes that happened. You're going to see some of the tornadoes and the damage pictures shown up on here. Drones can be very useful on some of this stuff. You can see up in one of our counties in central Minnesota, you can see that tornado track going through that field right there. And just once again, more drone information, just seeing the track to the trees there. So just to wrap things up here, WoFS provides an incredible utility to operational forecasters, especially once it's been able to have that warm-up period and take some observed convection and start simulating that with that already occurring. One of the challenges, though, with WoFS is the amount of data available is overwhelming, especially in warning operations. So the best utility we've found is to leverage people's expertise via various different rooms like the Sierra Meso room, any WoFS rooms if they're open, and also to make sure the focal point for WoFS discussions in an operational severe event is to be the meso analyst and to have all the data feed into them so they can take the highlights and brief the warning forecaster. And with that, that's all I have to present for today.